Okay, so let's go a little bit farther with our simple setup here. This shouldn't take too long, but it's worth doing and getting a better handle on how this actually works. So I'm leaving the system exactly as it was, right? So I've got this servo right here, which is the non-modified servo, the HS311, is hooked up to pin 11, and this one here, which is one of the servos for the wheels of the robot. It's a continuous rotation, and it's hooked up to pins 12, defined right here. Set up as outputs and setup, and I've got my sort of demos. Let's do another demo. Okay, we're going to play with each one with one more demo. So let's make a demo 2, and I'm going to copy this and paste it right there. Let's do a demo 2. And what I want to do in this particular case is make this guy go back and forth. Okay? So to do that, all I really need to do is, well, actually, let's do this. Let's start off with a for loop. We need some way to repetitively hit this servo and keep it in a position for a period of time. They're not infinitely fast. In fact, you saw it move. It's kind of slow. All right? So I'm going to need to pulse it many times, 20 or 30 at least, to get it give it time to make it to a position and then hold it there for a little bit. And I'm going to do that with a for loop. Okay, so I'm going to make a for loop. I'm going to create a variable in here I can work with. I like I. I'm going to set it equal to 0. And then from there, I'm going to, let's say 30 times. So let's keep I less than or equal to 30. All right, and then let's make I go up by 1. And let's frame that off like so. All right, and we'll tidy our code. Okay, so now we've got it, so it's going to hit it 30 times, right? So now let's just take this and copy it, and let's paste it right there. And instead of it going to 2,000, let's go to 1,000. Okay, so that's going to move to the opposite position. All right, and it's going to hit it for 30 times. So if I run this, let me comment that one out. If I run this code, we should see this servo move back and forth and back and forth. And lo and behold, there you go. It works perfect. So this would be an ideal mechanism for some sort of a walking robot or some other behavior, maybe in gameplay or a robot arm or something like that. So I can control it. And if I made these numbers a little bit smaller, let's make this say 1800, and let's make this one say 1200, you'll see that it does the same motion, but it won't travel as far. I'm going to put my mouse right there. And now you'll see it won't go to that same position. Still does the same behavior, but not nearly as far. Okay? So now let's do a simple demonstration with this servo. Let's go ahead and create another demo. I'll make a demo 3. 3, and I'm going to comment that one out. So now we're going to run demo 3, and I think I'm going to start with this, and I'm going to paste it right there. I'm going to change this to demo 3. And I think what I want to do is I want this guy to step through so he can watch it move through all the motions. So I'm going to make a big for loop, and I'm going to create another variable, I, and I'm going to set it equal to 1,000. And then I'm going to make it so that it goes, let's see, what do I want to do? Yeah, I'll just make it go till I is less than or equal to 2,000. And then I'm going to go I plus plus, and I'm going to polish that off like so. All right? And then go down here, tidy my control. And what I want to do is I want this number here to be my variable. Okay? So what should happen is we're going to start with 1,000, then we're going to go to 2,000, or 1,001, 1,002, 1,003. So if we run this, oops, I did not make that number big enough. There we go. 1,000 to 2,000, if you're following along. And I totally screwed this up. Why are you guys letting me do this? There we go. I is equal to 1,000. I is less than or equal to 2,000. I plus plus. Okay. Let's run demo 3. Oh, and I didn't change the pins. 1,000 apologies. We need to make this servo 1. Okay, let's do that again. I'm sorry. And you can see it's getting slower and slower and slower. Stops. And reverses direction. And if we want to see that, let's go ahead and do that. Let's do a, inside my loop, I'm going to do a serial.println, and I'm going to print I. Okay? And let me load this up. And I suspect that you can see that what it's actually going to be doing, it's hard to appreciate. It's auto-scaling too much. Let me show it to you this way. Now you can see the values changing. So as we approach 1,500, it comes to a complete stop, switches direction, works its way to 2,000. What I really should do is have this go in reverse so it doesn't get that sharp jolt where it switches directions. So let's do that as our last demonstration. I'm going to copy this. I'm going to paste it right there. I'm going to start at 2,000. I'm going to go while it's greater than or equal to 1,000, and I'm going to do a minus minus. Alright, so that way we'll get rid of that sharp jolt when it switches. Now if I load this, and we watch our serial monitor, we can see that it approaches 1,500, slows to a stop, switches directions, speeds up to 2,000, switches to the next for loop here in a moment. There it goes. Now it starts counting down, getting closer and closer to 1,500. Starts speeding up and reversing direction. Faster and faster and faster. And of course the process is going to repeat, so now it's starting to count back closer to 1,500. Okay? So you can see the system works pretty darn well, and some sort of movement like that, you know, if you had a robot, you could actually use it to make a serpentine movement like this with your robot, so it curves through the room like a snake. And that's actually kind of neat, because if you only have one forward sensor, you can have the sensor sort of scanning the horizon as the robot itself slithers forward in a room. But I think that's probably enough information to get you through the first sets of questions on the packet, and I will end it here, and I will see you all again soon.